Yeah, good morning and hello and welcome to our next webinar with the topic ABB Free at Home Wireless. Yeah, my name is Thorsten Reibel. I'm here together with Jürgen Schilder as always. And yeah, today we have another colleague in ABB Bujega in Lüdenscheid, Christian Krupper, the product manager, and he will do the most of the webinar today. Let's start. I would like to hand over now to Christian. He will talk about this topic. ABB Free at Home Wireless. Free at Home is not a complete new topic, but there is an extension now with wireless technology, and you will get all the information right now. So I hand over to Christian now. Just a moment, please.
Thanks, Thorsten, for the introduction, and welcome everyone. Today, I'd like to give you a short overview of Free at Home Wireless. Free at Home Wireless is an extension to our existing Free at Home portfolio, and we're going to have a short look on it. First of all, a word to myself. My name is Christian Krupper, and I'm the responsible product manager for Free at Home. This is what we are going to talk about today. So first of all, a short introduction about the Free at Home system, then some technical specification and installation guidelines. Afterwards, we are going to talk about the portfolio, so what devices are available, and lastly, how are these devices commissioned. If you are aware of our Free at Home system as it is today, you will probably recognize this image. This is the system topology of our existing system, which consists of various devices that are connected to a twisted pair bus system, along with a power supply and our system access points, which manages all the devices and also manages the programming and configuration by an app or by a desktop PC. And well, this is also the basis for our Free at Home wireless system. Free at Home wireless is not a new system. Instead, it is an addition to the existing system. So if you are aware of Free at Home and have programmed it already, the good news is you don't have to learn everything new again, but you can use the same programming, the same parameters that you know about Free at Home are still being used for Free at Home wireless. The only difference is that there are a number of additional devices that now do not only communicate by a bus wire, but communicate wirelessly. So in theory, there could be different system topologies. There could be systems for the retrofit market where you have an installation only with wireless devices, so with a system access point and a number of bus devices. Or you could have a mixed system combining wired devices, like you can see here, and additional wireless devices that can be added to the system. The single common device in this configuration is the system access point, where there will be a new version that replaces the existing one, and which has the functionality of a connection to the bus, but also a wireless connection for the wireless devices. Well, the USPs for our Free at Home system today is mostly the intuitive graphical programming that is done by, well, either an app or a PC, but also the easy installation because the devices are pre-configured, so you can install the devices and do not even need to program them, but can already use them. Also, there is a strong integration with our existing ABB welcome door entry system, and a remote service so that you can access the system when you're from your mobile, when you are not at home. And all of this is true for the system today. And of course, the same functionality is also true for free at home wireless. Additionally, however, our system is now suitable to be installed in a renovation situation. So what kinds of applications is free at home wireless useful for? So first of all, of course, you have an existing conventional switch installed in your home that you'd like to make intelligent, to switch it by an app or by a time program. That can be easily replaced by a flush mounted switch that is integrated into the free at home system. Furthermore, you could integrate or you could replace an existing room thermostat for underfloor heating, for instance, with a new intelligent free at home flush mounted device. And also you could replace an existing conventional thermostat that is used for your conventional heating radiators with an intelligent free at home integrated thermostat. So in a nutshell, the free at home wireless system is, well, not a new system, but instead it's an addition to the existing free at home list of devices and well, expands the applications that free at home can be used for. All the existing functionality that you might already know can be used as well with free at home wireless. And of course, also all the free at home wireless devices can be integrated into the existing switch design ranges that we have. So let's talk a little bit about the technical specification and some installation guidelines that you should know when you want to use free at home wireless. So first of all, what exactly is free at home wireless? Free at home wireless is a proprietary radio frequency protocol that uses the 2.4 gigahertz frequency band. That means in this system, you can only use free at home wireless devices. You cannot integrate Zigbee devices, for instance. So this is a closed system and you can only integrate devices that are part of the free at home system. The communication between the devices is encrypted right out of the box. So you do not you don't have to think about that. This is part of the commissioning process. Afterwards, all the communication is going to be encrypted. The system size is 64 devices for a pure wireless system. However, if you have a mixed situation, like we have seen in a previous slide, there could be additional 64 wired devices. So in a mixed situation, there could be, in theory, up to 138 devices combined of 64 wired devices and 64 wireless devices. Last important question is the range of the communication between two devices. This is also quite hard to answer because the physical installation has a big influence on the wireless range. So when communicating in line of sight, the range is up to 100 meter, but it's considerably less in a real world installation in a house. So we cannot give a concrete numbers for installation in the house because it's so different in a real world situation. But I will give you some clues in a couple of slides. What was also mentioned was that free at home wireless is a meshed network. So what does mesh network mean? Well, basically, every device within the free at home system does not only listen to radio frequency commands, but it also repeats them. In this example, we have a theoretic meshed free-at-home wireless network. This switch receives an information from the system access point, but it does not only receive it, it also transmits it to other devices in its range. So this room temperature controller receives a signal from the system access point, although it is not in direct reach of the system access point. Every device basically has this repeater functionality, except for the battery-driven devices. There are a couple of them, like this radiator thermostat or this window sensor. They are driven by battery, and therefore they do not repeat every signal in order to save battery life. But of course, using this technology, we can overcome a lot of the range restrictions that we face in a real-world situation. So here we have some installation guidelines. As I said, we cannot give concrete numbers about the range within a house. However, there are some basic rules that you should think of when planning a system. So first rule is to not jump over more than one floor when communicating between two devices. Instead, there should be at least one device in between in order to be able to repeat the signal. Same rule applies also for communicating between different rooms. So there should be at least one device in between the system access point and the switch when communicating between two walls. Yeah, and then there are some general advices that are basically physical restrictions, considering that we are dealing with a radio frequency transmission. For sure, you should not you should consider not to install the devices near big metal surfaces, for instance, like a stainless steel refrigerator or near mirrors, etc. And then you should also consider that different wall materials have different damping characteristics, like a freshly plastered wall damps the signal stronger than a dry wall. This is basically, yeah. Point that we have to keep in mind when installing free-at-home wireless is interferences with other RF systems. Mainly, this is these are Wi-Fi systems, 2.4 gigahertz, because they are transmitting in the same frequency band, and also they have the strongest signal. And because this is so important, we should have a deeper look into the situation with Wi-Fi. So basically, Wi-Fi and also free-at-home wireless share the same frequency band of 2.4 gigahertz. 2.4 gigahertz means, well, this is not only one frequency, but it's a frequency band starting at 2.4 gigahertz up to 2.483 gigahertz. And this frequency band is divided into different channels, channel 1 to channel 13. And what needs to be considered now, if you have multiple Wi-Fi routers in your home, is that these routers are using different channels that are not overlapping. Although you have 13 channels, you cannot use channel 1 and 2 when you when you're using two routers in close proximity to each other, because the signal would overlap each other and you would get interferences. So what should you do in that situation? You should pick channel 1 and channel 6, for instance, in order to to avoid any interferences. We have a similar topic with free at home, although, well, we share the same frequency band starting from 2.4 to 2.43 megahertz, but with considerable more channels. The interesting part is now when we have Wi-Fi and also free at home wireless in one home. So the basic rule is when you're using both technologies in parallel together in one home, you should make sure that the free at home channel is set to a frequency that does not overlap with the frequency of your Wi-Fi router. By default, the free at home wireless channel is set to channel 26 as marked here, but it can be changed manually later on. Wi-Fi routers tend to pick lesser channels, although if you experience problems with your free at home Wi-Fi receptibility, you can change the channel, and once you select a different channel within your system access point of free at home, you will get a recommendation which channel to pick, which has the least interferences with other Wi-Fi networks. This is an example how a real-world situation might look like. This is a screenshot from a free software called Wi-Fi Scanner, but there are also different ones available. This is just the one that I picked. And here we can see on the lower left-hand side the situation of the 2.4 gigahertz band, and on the right-hand side the 5 gigahertz band. For us, interesting is only the 2.4 gigahertz band, and we can see that it's quite crowded. So basically, all the frequencies or the channels are used by different routers. However, most of them are not very strong. They are damped due to due to walls, etc. The Wi-Fi that is within the home is this network called ASUS. It's on channel 1. So in this situation, it would be safe to select channel 26 of free at home without experiencing any problems, any interferences with other Wi-Fis. But as I said, normally you should not be able to use this kind of analysis because free at home is going to give you any recommendation which channel to pick. Okay, now we are coming to the portfolio. So what kind of devices are available within free at home wireless? Here we have a little overview about the different types of devices. On the upper right hand side, we have the thermostat for conventional radiators, which is a battery driven device. It incorporates a temperature sensor as well as a room temperature controller. So you do not need any additional device to use this. It can just be exchanged with your existing conventional thermostat, and can directly be used. You can set the temperature directly at the device, or switch it off, or put it into eco mode. And of course, you can use all the benefits of the free at home system, like doing a time program where this device wakes up or goes to sleep at a certain schedule, or you can control it by the app with your phone. Next, we have a flush mounted room temperature controller. This device is also available with an attached actuator, so you can use it to replace your conventional thermostat to control your underfloor heating, for instance. Next, we have devices to control blinds and shading, devices to switch the light, either by a manual operation or also automatic by movement detectors. Then we have light dimming devices. And we have this kind of sensor that is also battery driven and that is installed between the frame of your window and the window handle. And this device basically recognizes the status of the handle of your window. So you can see whether the window is closed or open, and can receive, for instance, a message within your free at home system that you forgot to close the window. Also, you could set the room temperature controller to eco mode as soon as the window is opened. Last but not least, we have this system access point, which is also new. It looks very much like the existing system access point, although it has a new functionality. The old access point only had a connection to the twisted pair free at home bus and to TCP/IP. This device has an additional interface to the free at home wireless devices, and it is going to replace the old access point. So in future, we will only have one single system access point, and this device can be used either for wired installation or wireless installations or mixed installations. So there's always only one central device. When we're looking at our flush mounted devices, we discriminate between two different ranges. Call it the one range we call range 60, the other one we call range 44. These are essentially, well, technically they are the same devices. They have the same technical specification, the same current reading, etc., etc. The difference is basically within the adaptation to the design range. So in one country, you will find an aesthetical design like, I don't know, Sidus in Switzerland, for instance. There only range 44 will fit. And in other countries, like in Germany, you will only find range 60 devices. So it's not, the technology is the same between the two. It's only a matter of adaptation to local switch ranges. And of these, we have quite a lot. This is an overview. This is an overview that is true for free at home, for the existing free at home wired devices already. And it is also true for free at home wireless, because all the existing plastic parts that we have introduced since the launch of free at home, all these plastic parts are still compatible with free at home wireless. So you can, if you have these plastic parts today, you can simply use them for free at home wireless as well. There's one little exception, which is the movement detector for range 44. The reason for that is that the new movement detector needs an additional button that has to be accessible by the user, which is used for resetting the device. And yeah, due to that reason, there needs to be a new cover plate for these movement detectors. But other than that, all plastic parts stay the same. This is a complete list of available devices, starting with a new access point. Then we have an optional external antenna. This is meant for the access point. So in situations where the system access point is installed in a cabinet, for instance, then you could use this external antenna to reroute the free at home wireless signal to the outside of the enclosure. But this is usually not needed. So only if you have an enclosure of metal where the wireless signal is blocked, then you can use this external antenna to to route the wireless signal outside of the box. Then we have a couple of the window sensors in different colors. Here we have the radiator thermostat together with some adapters that might be needed depending on which kind of valve system you are using at your radiators. The device comes equipped with a number of adapters. However, there are some exotic valves that need an additional adapter. In that case, well, we have them available as well in our catalog. And then lastly, we have the different flush-mounted devices in range 60 and range 44. As you can see here, for every position, there's an equivalent in every range. So there's no difference in functionality between range 60 and range 44. So here we have an overview about the flush-mounted devices and their functionality with the example of the range 60. The same situation with range 44, but yeah, here a little bit more detail for range 60. If you are aware of our free-at-home wired system already, then you will recognize that the functionality is exactly the same like with free-at-home wired. In fact, also the article codes are exactly the same, with a little exception that we have this addition of the -WL at the end. But if you want to compare devices from wired to wireless, you can simply do that with the article code and just leave out this -WL ending, and then you have the equivalent product of the free-at-home wired system. One product that we did not have in the free-at-home wired system is this room thermostat, including an actuator. So this is in fact the only new addition to this portfolio. Okay, now we come to some details of the devices. First of all, sensor units, which are used only for interfacing the system without a switching actuator. They are being connected to L and N. And the same is true for all other devices. All of the devices need L and N. In this case, we have a switching actuator. Here we can connect the load, of course. And then we have an auxiliary input for cases where you would like to use a conventional switch in parallel in order to trigger the load in this case. And this auxiliary input is available, whenever there's a switched output, there's also an auxiliary input. Like here in the two-fold, two-gang actuator, we have two outputs for loads and also two inputs for auxiliary inputs. And again, the technical specification is mostly the same like for free-at-home wired. So also the free-at-home wired devices were spec'd for 200 and 300 watts. Now we are coming to the dimmer. Same situation here, L and N connection, a dimmed output, and also a auxiliary input. This device is special in that way that this is the only device that can optionally be used also without N. The load characteristics will change a little bit. So the minimum load is higher in two-wire mode, But other than that, this device can very well be used when you don't have an N in your wall box. Next, we have the blind actuator. Again, same situation here. 2 outputs for up and down movement and 2 inputs for auxiliary inputs. Lastly, we have our room thermostats. The upper one is only a sensor. It needs to be connected to L and N. And the lower one includes a switched output that can be used for underfloor heating, also for electrical underfloor heating, because the device is spec'd for up to 16 amperes of load. Both of the devices feature a connection for an external temperature sensor. This is an optional device, so both devices have an internal temperature sensor to measure the room temperature of the air. But if you connect additionally the external temperature sensor, you could use it to either measure the floor temperature and regulate the floor temperature. So when you like to say, okay, in my bathroom, I'd like to have a constant floor temperature of 22 degrees, you could use this mode. But there's also another mode available where you could use this external temperature as a limiter for the temperature. So let's say you have a delicate wooden floor that should not exceed a temperature of 30 degrees, then you could use this external temperature sensor to limit this temperature and switch off the heating as soon as the heat exceeds a certain value. Here we have the topology of a theoretical free-at-home wireless system. So all the devices are connected to mains by L and N and connected to a load. And all the devices are communicating wirelessly with a system access point. The system access point itself can be controlled by your mobile device or by your laptop. And this is connected by Wi-Fi or also by local area network. Okay, next we come to commissioning of the system. The whole free-at-home system is commissioned with a very easy graphical user interface. This is the main menu of this user interface, and it's basically it uses drag and drop gestures where you can position, where you can draw a floor plan of your house. You can position the devices on this floor plan, and you can make logical connections between these devices. But this is already known from the existing free-at-home system, and it is the same with free-at-home wireless. So if you know about that already, and if you have done that, you can do that with free-at-home wireless as well, because there's nothing new. However, one thing is new, and this is the you have to bring the new free-at-home wireless devices into the system somehow. They are not connected by a bus. They are communicating wirelessly. So, well, at some point, this connection needs to be made. And I'd like to show you how this is done now. Fortunately, it's also quite easy. So first of all, you are mechanically exchanging the existing switch with a new free-at-home wireless switch. Afterwards, you turn the device on, and then automatically it will enter teach-in mode for 30 minutes. So as long as the device is in factory new settings, it will enter teach-in mode after first power on. What you do next is you connect with your system access point, go into the settings menu, enter the wireless setup menu, hit the scan button, and then the access point is going to include all the devices within your house that are in teach-in mode right now, all of them are going to be added to this one installation. This might take a couple of minutes because the devices need to look for each other. But after about, 15 minutes or also earlier, the devices will appear in your user interface. And after that, it's only, you can go on with the commissioning as you're used to, as shown in on the screen before. So why does it take a couple of minutes until the devices are introduced into the system? To explain that, we have to have a look how this teach-in mode works. As I explained earlier, the system access point is set by default to channel 26, and it stays there. It does not change its channel by itself. However, all the other devices that are in teach-in mode, they do change their channel. And they change it every 15 seconds. They do not always start at channel 12, but it's each device starts at a random channel number. This is to provide that not all devices are communicating at the same time on the same channel, because in that case we would get interferences. So what the devices do is they start communicating, let's say at channel 12, and they will ask for any system access point that is in scanning mode where they could enter the system. If they do not get an answer, they will hop to the next channel, do the same thing again until they finally hit the same channel that the access point is asking for. I also mentioned that the free at home communication is by default encrypted. How is that done? Once the device enters the teach-in mode, it communicates with the access point and tells him that it's in teach-in mode. And this message is already encrypted with a master key. This master key is programmed into every free at home device, and it's a secret key that is only known to ABB. And that is used only for the initial communication phase. Once the access point received this information, the access point by itself is going to generate a new unique key that is generated by the access point itself. So it's not programmed in, it's something that is randomly generated by the time that the access point is started. And this key is being communicated back to each device. And after teach-in has been handled, this new unique key is being used for encryption of the communication between the devices. Therefore, it is very important that this free at home key is being backed up, because this is the only way to retrieve a backup of your system in case of when the system access point goes defective and you would like to back up your system on a new access point. You need this free at home key in order to get access to all these devices, because these devices are going to be going to stay in with this free at home key until they are reset to factory defaults. So very important key. Always have a backup of this one. And last but not least, how does that reset to factory default work? Quite simple. Just push down the lower left-hand button and keep it pressed. Turn on the device. Wait for 15 seconds until when the light starts flashing and turns off flashing. the device is reset to factory defaults and can be added to a new system. Okay, this was it for my short overview of the system. And now I'd like to hand over back to Thorsten.
Yeah, thank you, Christian. Great. It was a good, compressed presentation. I think you got a lot of information already. Allow me to emphasize a few points. You did not see any DIN rail components here. Why not? Because we don't need it as a wireless version, at least. You know, in free at home wired, we have already DIN rail components to be installed in the distribution board. And as mentioned by Christian, of course, you can combine both solutions, both systems, and of course, you can use then the classical wired DIN rail free at home components to implement it in a wireless solution finally. Yeah. So no problem to mix everything. Okay, good. Okay, so far I hope we have answered all the questions more or less. I will check later on again all these questions, and maybe if there's something open, we will answer it in the feedback email. And I will also maybe summarize the most important questions from the morning session and from the session right now to be answered then in the feedback email. Good. So far we are finished with this part. I have still 2-3 slides left. So Christian, please
Yes.
move the ball to me as a presenter. I would like to show you some final slides. Okay, we have still something for you here on our homepage. Some maybe news for you. We have here the engineering guide database. Maybe it's new for some of you, where we have some content around some tools, for example, but have a look there. But there are also some technical information to support during the design and installation of our building automation solutions. Not only KNX, not only free at home, also door entry will be there. So have a look. And furthermore, we have this also relatively new portal, frequently asked questions. So we collect here questions mainly from our helpline around our products, our solutions, and then we will publish also the answers and the questions if they are interesting for many of you. And last but not least, the training and qualification database, the training selector, where we also store all our content for any kind of trainings, including these webinars, the recorded video, and also the presentation. So have a look there. It will be growing. All these platforms will be growing in the future, and there's all the content we have and we create together. Then final slide. A preview to our next webinar coming next year, of course. Wednesday, the 25th of January, at the same time, in the morning, in the evening, or in the afternoon. And it will deal again with a logic controller, ABAS 1-to-1 we did in the last webinar, but some more details, mainly a practical demonstration of all the functions, graphical programming, user interface, and some more information about the functional elements. So it will be very, let me say, practical demonstration and demonstration of this component and the solutions behind, of course. Good. We have reached the end. It's 4 o'clock here in Germany. It was the last webinar for this year. So we say thank you to you, to all of you who participated in these webinars, and wish you Merry Christmas and everything, good fortune, health, and for the next year. But we see us, of course, hopefully next year, and maybe next time at the 25th of January. So thank you. Goodbye. Ciao. See you next time.